some Internet of Things and urban sustainability applications that exist today and that have been evaluated today. One is an example of sensing, and the other is an example of sort of how other systems can influence behavioral change. So sensing in the urban environment is, of course, a sort of major focus of IoT applications, and it's naturally fundamentally driven by the exchange of information with infrastructure. And one of the key applications that has been done and tested on a large scale is that of information in parking. So this is an example right here in San Francisco with SF Park, and you've probably seen that application if you've driven around and parked on the street in San Francisco. And this involved a massive deployment of sensors in the ground to detect the presence of vehicles and then aggregated that information in order for SFMTA to make parking decisions, so to be able to better balance the pricing of parking. Parking had been, on-street parking had been historically priced very low. And so the idea was to test this, can we use information to improve and balance pricing with actual demand. And you can see here on the bottom a result of an evaluation of just a section of that over time SFMTA was able to lower the occupancies of high occupancy blocks using this information. Now, one of the interesting things that emerged from this application, some sort of lessons learned, was that the sensing was really defined to be sort of highly accurate and to really count the occupancy by second. And it turned out that they didn't need that highly accurate information. They only needed information that was, say, aggregated at the block level in order to make effective decisions to reduce occupancy. So with all of these IoT applications, one of the things that has come up in several cases, and certainly in this case, is that accurate information is good, but sometimes just partially good, accurate or proximate information is just as good and can be far more cost effective. And there's another aspect to this on the side of shared mobility, where we want to evaluate behavioral change. So shared mobility systems like car sharing and bike sharing are among the early, what we call connected vehicles, not in the sense of communicating on the road, but in communicating with the systems and communicating with people. And so measuring how these systems change behavior is an important area of research, particularly in our work, where we want to understand sort of how people change their travel as a result of interfacing with these systems, but we also want to understand how they would have traveled in the absence of this system. And so there's a hypothetical alternative future that we want to be able to measure as best we possibly can. And that's difficult to do. Naturally, as time goes on, it's harder to imagine what the world would look like in the absence of these systems. But when we want to understand sort of what these systems have done and how they're changing emissions and whatnot, we also want to understand what the world would have looked like in their absence. And shared mobility is a good example where we're evaluating that all the time in the context of bike sharing systems and also car sharing systems. So overall, in terms of trends and challenges, I mean, cost-effective solutions are generally critical for sensing, and rapid scalability, of course, is something that's key to success. And so what we'll see as the future moves on is applications of existing resources and how they provide new information overlays to existing infrastructure. So thank you.